Hi folks, sorry if we didn't have any audio and just a blob going for a moment in the beginning. I may have had those settings reversed. As you know, I'm not the tech wizard out of any potential future team I'll have, and it's hard being the entire team myself, but hopefully you can hear me now. I already gave a little intro that I'll to a degree repeat, where I was noting that we put a lot of alliteration in the title to embrace that we are having an August assembly in the anti-afternoon here, which is the night, and it is almost August. And also anecdotes, and lots of A's can be thrown in the mix. And I noted how I wanted to give a shout out to any aliens who may be watching this in the present or future who cannot understand that alliterative title. If anyone from another planet is watching this someday, the title will need a translational asterisk, a little bit where sometimes you read an old book and you need a little asterisk that sends you down to the bottom of the page and says, back in the day, this was funny because it was a reference to so-and-so. You know, when I write my books, I try and avoid those, and it's hard because it's fun to like wordplay. It's fun to like language-dependent traits like alliteration. It's fun to like base-dependent traits at times, as long as we acknowledge that they're stuck in the base. Like when we look at, 9 does wacky things in base 10. And really we can strip that down to, well, the number 1 less than the base does cool things in any base number. But we live in a base 10 society, so we might as well have fun with the patterns that show up around us there. Same with alliteration. I'm stuck in an English-speaking society. I'm not even the biggest fan of how the English language is put together. We could improve this thing. It's evolved a lot over time, and I'm a little worried that the English language evolved more in the past. It still is evolving, arguably just as faster, but I'm worried there could be a point where globalization and the internet does freeze definitions in one place, as opposed to letting words be added, even letters be added or subtracted. Like, whenever I say we should kick the letter C out of the alphabet, some people don't like that. However, we gotta be willing to embrace change, you know. First, I'll get everyone putting threeven in the dictionary, and then we'll plant the seeds that someday have zeros on top of clocks, someday have a better calendar structure. Speaking of the calendar, it's the beginning of August should be 7/12 of the year, but today on August 2nd for me is probably actually 7/12 of the year, because February's weird. So, can't even gauge the year's amount based on what month you're in. Can't gauge the language properly because C, X, and Q are doing double. And by double, I mean another letter is doing their job just fine. We could add some letters to take care of some of the weird H additions and other sounds that we double up letters or throw an H after to make. But we can subtract letters to have room for whatever we want to add. C isn't doing anything, Q isn't doing anything, X isn't doing anything. Somebody commented once on one of the posts that there's a popular Twitch streamer called XQC. Oh boy, you picked the wrong name, unless that's like his initials or something. Those are the 3 letters we're going after, man. Sorry. I don't really know that much about the guy. However, you know, he picked the wrong 3 letters. Those are the 3 letters that at least one of those should vanish from the language before long. You know how recent J and W are? People don't realize. I did make some language episodes a while ago, and on that topic, sometimes I like to diverge from math, although we will be talking about math in this stream in a minute. And, you know, let's edit the equation while we chat. I threw on a background equation that was completely random. I forgot which ones looked cool last time that made cool optical illusions. I was like, okay, polar coordinate, throw some sines and a theta. And it automatically looked cool. Equations just do the work for you sometimes. When you have tools like a graphing calculator and like, let's call that sine tangent instead, we can get very cool things just going in front of us. Tangent freezes it up a bit too much because Tangents are trippier than sines in the direction this is trying to analyze it. But we could do other things. We could say, like, what about the square root of that? Okay, this one's not changing as much. So, let's now say divided by. I just want to edit some different backgrounds while we chat so we can see some different ranges. It doesn't like this. Oh, that's because I just have sine on top. So we need something like theta over sine theta. Doesn't like that. Doesn't like any of these. I like the old ones we were trying. We're just going to do a few extra right now. We'll just have a blob doing funny stuff for now. Okay, it's going too crazy. Pause the blob. In any case, we don't need the background equation for a moment. I'll pull open something else as an example of, I wanted to note what our upcoming combo class stuff will contain. And I am most focused on the episodes I make for my main combo class channel, this one, where all my best episodes go. And if you're a true combo lord, someday, I'll make playlists to make this easier sometime, but someday hit sort through oldest. They're not that old, it's a year ago. There's about 50 of them. I think the next one will be the 50th. And they go in order. There's a little lore. And part of that strange lore that has developed is every 5 to 10 episodes, in between the math and language and philosophy, I steer toward what I call a snack break. Now, that's partially just because some topics already related to botany, or a topic was more casual and I wanted to weave it in that direction, or something along those lines. But these snack breaks have evolved in a fun way and provide a core element of our grade structure. And in grade -1, as we began, our official snack breaks began with a quite casual one that I called a lunch break, but I believe I called it a snack break in there as well. Our one I called the snack break about apple experiments. One that almost feels like a snack break to me, but is more of a science break about bubble experiments, because I don't think I actually eat anything in that episode. And there's a few more. We have burning the spikes of a cactus fruit, and we have the pumpkinberry conspiracies. And if anything, before our next combo class episode, you might want to watch this one, our Halloween special, because that had some facts about fruits secretly, botanically being berries in disguise, different sorts of berries. However, our next episode is going to be another snack break. This is the latest one. Make sure you've seen that one. Came out 2 days ago. That one's cool. But the next one is going to be a break from math. We've done a lot of math in a row. And although I know a lot of you love math, and I know it's one of the topics I know the most about and have most brainstorms ready, at the same time, there are other topics sometimes waiting in my notes, waiting to meet the world. And one that has been planned since the beginning, since grade -0, since when I was planning grade -1. One that occurred since right at the beginning was what I call the edible peel conspiracy. Because this is something that I have noted over the years, not just as a mathematician, but also as a fruit lover. And I want you folks to think, without trying anything yet, this episode will have a warning at the beginning and the end, not to try me. If you see me eat weird stuff, treat it as I'm eating enough for all of us. You don't need to copy it. You have now seen a human try that. I'm doing it for both of us, so no copying. But in this episode, we're going to go pretty wild with what I'm going to call the edible peel conspiracy. And I'm editing that episode right now. There's only 1 or 2 more shots to film on that tomorrow. It's really fun. Even though it's a snack break, a lot of cool scenes in that. And as I was investigating it, I'm not going to say exactly all the details of what the edible peel conspiracy is until that episode should be out probably the weekend or so. But I will say that as I began filming that episode, I was considering the title The Edible Peel Conspiracy, or that's either going to be the title or on the thumbnail or something. I say it in the intro. I was considering that title as 90% a joke. Maybe there's a little conspiracy going on here in a slightly joking way, but I'm using the word conspiracy as a joke. Typically, I'm not a conspiracy theorist, despite loving strange thoughts. They're typically hypotheses. I don't get too committed to believing that's definitely a true conspiracy. I find it funny. I'm willing to debate some flat earthers or some people like that someday. But this thing, I almost feel like I'm stumbling into what's worth calling a conspiracy. As I continued filming the episode, I realized maybe it's half a joke. Maybe the title, The Edible Peel Conspiracy, is half joking and half dead serious. Same with the tone of the general episode. And we'll see this weekend on not me unraveling the world's flat type of conspiracy. The real conspiracies are little seeds of possible manipulation that things in power, like corporations, might be doing to us. Of course, don't be a conspiracy theorist. Treat everything like a hypothesis. Don't get addicted to thinking a source you read that seemed cool and mysterious was true. Like I said in our last stream, a lot of people are talking about aliens after this Congress hearing thing. And although it's cool that Congress is talking about aliens, I looked into it a little more, and I maintain my belief. I have gotten further into 99 or more % sure that all the details that guy told Congress about aliens are not true. Or if they're true, they don't line up with things he's said in other interviews. And it just doesn't line up with what I imagine being possible for the actual state of the world. It holds America up to a strangely glorified height that I don't think America actually has. I think America is just a random one of the countries, and America is a little more developed than some other nations, and people here have it a little easier sometimes. Sometimes there's a little more freedom, a little more chaos, a little more different things here. But in general, I don't know why aliens would be centered around America, or why, if aliens were centered around the world, why America would be in charge of the secrets. Sorry, super patriotic people. It's cool. I like the freedom aspects of America, and I like certain things about it. I like that, I was born in here. I like the Bay Area, where I am at least. Sort of strange part of America, but sorry, I'm not hyper-patriotic, and we have to note that if aliens ever land, if there's a conspiracy you believe that involves more than 10 aliens crash landing on Earth by accident, let's assume they crash landed in different places, or maybe all in the same spot, but why would it be America? Come on, it's boring here, guys. There's way cooler stuff out in the world. America, we got a lot of freedom and stuff, but the aliens would go to see some cooler rainforest, or they're probably going undersea to see some type of species we don't even know about that lives in some deep sea vent. Those are the real aliens to investigate, because they're closer. They're not technically aliens, not from another planet, but we don't know everything about the deep sea. We know a decent amount. There's probably not some mysterious hyper squid living down there, but there's probably some species that live in strange climates near really hot volcano-like deep sea vents that are very different than the type of life we're used to, because where they're down there is not only surrounding area of really cold, but a blastingly hot vent, but also the pressure is insane. When you go down there, like if you scuba dive, you can't come back up right away. You have to do a very careful technique to rise slowly, because the pressure messes with the human body if you even go 100 feet down. So when you go like 1,000 feet down, we have decent pictures and stuff to a degree of some areas of that, but we don't know all of the Earth's aliens that are living down there as well. Somebody said the music goes hard. Thank you. Let me know if it's ever too loud or if you can't hear it at all, because right now I am playing a playlist of beats I made. These are Domotro beats. These are beats that will be turned into songs involving rapping and singing and a few more layers of instruments added on top of them, as well as being the beats that I use in my combo class episodes. So you probably hear a clearer mix of some of the beats in their whole form when we do these room streams that are the same beats that I put in the background of combo class, much quieter. So I guess the comment came in right after I said that, where I got it. I made these. I make a lot of music, so when I start dropping music on this channel, I hope my true fans approach it from knowing that I used to teach at a music shop and that I've released more than 10 album-length projects that I haven't shown you yet and stuff like that, that I play many instruments, spent many years rapping and singing and stuff, that it's not just going to be another cheesy YouTuber saying, oh, why don't we make a song? That sounds like I can make a random hit song. I've been making music like I always have been, and before too long, occasionally I'll put a music video on this channel of finished stuff, and might involve some rapping, and if people think, oh god, that sounds so cheesy, this white YouTuber rapping, please give me a chance, because it's something that I actually have treated as an art for many years. So, it'll be cool. Now, this channel's the experiment zone. I think of if we have a combo class school. The other combo class channel is more exclusive, well-developed classrooms and gardens in the back. And here is sort of our courtyard. When I post videos on here, we get much more random comments. People strolled by from a short, people strolled by from a stream, or all sorts of different options. Now, I don't have any graphs going at the moment. Why don't we transition to one of our mathematical topics I wanted to talk about. Now, let's answer a few more comments. Let me see back on what our comments have said, and then we will jump into some stuff that's a sequel to our 3x+1 episode that I dropped. I am bad at promoting this channel in terms of telling people what YouTubers should say, like, watch all of my videos, they're good. I'm real with you guys, I can't fake that. I watch YouTube too, so I'll give you real recommendations, like, if you're watching this stream and you haven't seen that episode and you're interested in the Collatz conjecture, feel free to quit the stream and watch that episode instead, and then come back where you left from. That episode would probably make more sense in a viewer's brain to come before the stream, but it's okay if you don't know, because if you haven't seen the episode, it is a really simple problem. Now, it's okay that I'm bad at promoting this channel because I just have fun on this channel and it's working excellent. This channel is still less than a year old, and we're just flying up there in the subscribers. Many from shorts, but it's really awesome how many people are around here commenting, showing frequent faces. There's a Discord that a lot of people chat in. A lot of cool stuff. There is, I should note real quick, no, I'll note this later. It'll be annoying if I note it now. I'll note it later. So, let's jump into some math topics. Somebody is saying, can they use it in a geometry dash level? They're trying to find a song that fits something. I'm not sure what you mean use it in a level, because I think that's a game that, does it already have soundtracks or none? Do you mean, can you use it in a video of you playing Geometry Dash? If anybody wants to use any of my content, I am totally fine with it, but I would really like if you credit me. I probably won't ever sue anybody for using it, even if they don't credit me, but if you credit me, then I'm definitely cool with it for now. If you say, by the way, here's my video, and somewhere in the description say, the beat was made by Domotro, who's from Combo Class, and put a link to one of my channels. Then you guys can use my music or my videos or whatever for whatever you want. It would be great. It would even help us get the name out there. So if anybody wants to, I even recommend it. You know, put my videos on any social media you want, as long as you link that it originally came from this channel or the Combo Class channel or whatever. But you say it as an editor in the game and you get to put in music. If it's just something that you just put it in for you and your friends, totally. Now, here's the thing. I haven't posted all these beats for everybody. I did put them on Patreon once. I put a link to a soundtrack amount of beats I had made once on Patreon. It wasn't fully polished. And I was like, these are beats I'm going to put out for free to everyone at some point. Here's the unpolished versions way early for my Patreon supporters of a certain tier. Now, let me get some water. One second. Now, I am going to release those beats to everybody and more, because if I tell you how much music I've made, it'll probably sound like I'm exaggerating or lying. I spent a disproportionate amount of time creating whole songs of different sorts, some of which I released in different ways. From the time I was about 15 to 20 or 25, I still do that a lot, but I spent extra time back then. Now, for example, one story that I kind of mentioned once, I think, but I haven't fully told, is I made a CD that was an album of my old beats that were, at that point, I was using samples from weird cartoons, from like Looney Tunes and from like stuff like these games, if anyone used to play these. These are some of the only video games I ever genuinely enjoyed. Point and click mystery adventures with clues and stuff and cool animations. These had good soundtracks, and I would sample those too. So I had these sample-based beats that I made on one of the many projects I'd made when I was a senior in high school, when I was 17, about to graduate and turn 18. And I really awkwardly gave it out to a bunch of people in my high school in the last week. And I should have probably called it an album looking back on it, because the only reason I called it a mixtape was because I was like, I have bigger dreams. I can make better albums someday. And plus, this has some samples from these things, so it's not 100% made by me. But then when I told a lot of people, here's my mixtape, I think they thought I just meant a mixtape of various songs I liked. And then they like probably put it on and they're like, whoa, this is the guy. This is him. Because it was a rap album, and I don't think any of them knew I rapped. And there were many other musical projects I've released over the years, but there's not an MP3 of these beats available for non-Patreon people right now, but I'll try and get it ready at some point before long. I am in the process. I've been a little late on putting up cool stuff for the Patreon people, but I'm in the process of merging that with this YouTube thing. YouTube, I mentioned once, sent me an email last month, or maybe the month before, that said, if you set up memberships on YouTube, they didn't offer this to the Combo Class channel. And by the way, YouTube, if anyone from YouTube's watching this, I love YouTube. Sorry if I'm ever brutally honest about anything. This is going to be a pro YouTube thing. But in general, I'll be very honest about the ways that YouTube communicates with me. I think that's important. Honesty with, there's another force. You're watching my videos and I'm like responding to the algorithm and occasionally an email or offer from YouTube. So I want to keep you in on the other layer. And I got an email from them that's like, if you set up memberships here, we'll give you $500. And if 30 or more people sign up the first month you do it, we'll give you another $500. And that is a lot of money to me. I don't know if you guys understand, maybe some of you treat money differently, but I don't eat food out much or anything. I live at my parents' house. I spend pretty much all my money. I spend a little money on myself, but pretty much all of it on Combo Class. And that would be a lot of money to me. That would really help Combo Class. And what it helps, to be specific, is I hire more people throughout the week to help me turn my ideas from just chaotic live streams to more hours I can hire camera people, and in the future, maybe more hours I can hire editors and turn my chaotic live streams into, each live stream has so many random ideas in it, it could be turned into 3 videos with the right editor. But, so, with that known, Okay, I'm going on long rants here, and we haven't even gotten to the math topic. But what I was going to say is, real quick, I did set up the memberships thing, but I didn't add anything to it yet. I set it up already so that I think I'm on time for the deadline. I'm not sure if YouTube's going to give me the 500. It's kind of weird how their offers work, so I haven't seen it come in yet. I'm not positive, but I'm hoping for it, and I did it in, I think, by the deadline. So I put up the thing called memberships on this channel for that reason, because $500 will make some better videos this month. It'll hire cooler camera hours, extra help from other people, maybe trips to cool locations and so on. And I didn't add anything cool to it yet. But if anyone wants to sign up, if they wanted to support Combo Class but don't use Patreon, or they're using the Patreon but would rather do it through YouTube, I'm gonna end up putting the same stuff on both, hopefully. Hopefully I can make it so it's the same stuff that I offer that you get on your Patreon or you get on that. I put up a little bonus stuff for those people, and normally when I'm working with more editors, I have so much bonus content that in the long run, there should be like a bonus video every week for those people with all the extra stuff I have. I haven't been good at taking as much time to edit stuff for them while I'm merging the two, but there's some fun bonus stuff there. Mostly it's it for people who happen to already be like eating well enough that they want to, you know, send a little money through the world to support us. That more for people who like our dream and would like to see it grow. And I promise you folks, if I ever even got mildly rich, first of all, it would all go to Combo Class. And if we have any extra that first we can't use to, if there's any that there's nothing in Combo Class that can be perfectly maximized with that, we will create cool educational charities and do good things with it. I don't care about money, we'll send it away. I would give away money to fans, but I'm not the type of YouTuber who does like for clickbait, make the title, I gave away this much money to a fan. If with my best guess of who I should give money to, the fans are the ones who have enough time to be watching my videos and more likely than not are under a safe roof. And, you know, even though I'd love to give the money to the fans for some clickbait or whatever, a lot of YouTubers do that. I believe in other charities. I actually really like what the YouTuber Mr. Beast has done. The biggest single YouTuber on the planet. Makes kind of cheesy videos, but he genuinely has really helped the world. As a mathematical perspective, anybody who says that all of his philanthropic efforts are him being greedy or something, they are completely delusional and losing track of the point. If anybody spends enough of their time and gives away enough of their money and works really hard to like help oceans and trees and food banks and stuff, that's cool. So I really respect that. More YouTubers should do that. Which is why I don't mind, even though that guy's videos can be cheesy at times. I'm happy he's the biggest solo YouTuber because he's a good person. As far as I can tell. So, got some other cool comments. I'm going to move on to our mathematical topic in a moment. Now, we had been looking in our last episode about the Collatz conjecture. If you haven't seen this, it's okay, but this was the last Combo Class episode. Sometimes what I like to do, mention the coolest. You have a main episode, have an arc, and then a quick mention of all the coolest of the other things about the topic to me. I can't fit everything in. If I try and fit everything into an episode, we're only going to get an hour-long episode once a month. And I think it makes more sense to have a 15-minute episode a week than an hour-long a month. So sometimes I got to cut the episodes and be like, maybe I'll have to return to this topic. It's so grandiose. But usually there's a little arc and then some bonus things. And a good time for the streams, or a good topic for the streams, is to delve deeper into those bonus things. And the main topic of this was the binary part. As we can see, So we won't talk about that in the stream so that we won't spoil it for anyone who wants to watch it later. What we will spoil is 30 seconds out of the episode when I mentioned that we can extend this to other realms of numbers. So, for example, negative numbers. Now, I want to explain this process a little more clearly. Here is, for people who don't know, a little definition. This is a site called Wolfram Math World. Wolfram is normally a graphing calculator site, among other things. That's what it's most known for here. But they have a lot of cool resources. The Math World one, sort of Wikipedia-esque. Maybe less info, but more trustworthy info. From what I've gauged. So, like, maybe a little closer to 100% trustworthy. Nothing is 100%, but this might be a little closer than Wikipedia, but they don't have quite as much info. Sometimes you click one of their links and you're like, oh, you don't have an article about non-zero integers. You only have those separate. Or like you click one and it's a one sentence thing, as opposed to Wikipedia being more like a rabbit hole maze. But here they got some good definitions. It's one guy who writes a lot of these, it seems. I keep seeing this name on a bunch of these. Let's see if it's the same. Yeah, this guy, Eric Weisstein, seems to write maybe all of them or just a huge amount of these. So whenever we credit Wolfram Math World, when we're like looking at, some random, we need to show somebody else's examples of something I'm talking about for visual purposes or whatever, they can sometimes be good. Often this guy's coming through. So shout out Eric W. Weisstein. Now, the Collatz conjecture basically says, if you take any positive integer, any whole number bigger than 0, and if it's even, you divide it by 2. And if it's and you do the same with the result. When you get to a new number, you do the process again. At any stage, if it's even, you divide by 2. If it's odd, you triple it and add 1. And then you see where they go. Well, all the numbers ever discovered so far fall into 421, 421, 421. And there's a lot of visualizations of that I did in the episode. There's also a lot of really cool ways you can see the visualizations. Let's see what Wikipedia happens to have for a tree of it. Because I want to see a Collatz tree. And wow, so this isn't Wikipedia. Let's look at Google Images, though, just to see an overview of different ways people have visualized this. So this is closer to the one I created in the episode. I mean, it's not the same exact, but this is closer to the way I represented it in the episode. Numbers fall into these chains that lead to other chains. They go down to 421 and loop back around. Although this one might be backwards, or I can't even tell which way this one's going. That's doing something else. But there's a lot of ways that people visualize it, like trees. This is sort of like the one I did in the episode. It was just a cutscene. I showed it other ways too, but you can see a tree of numbers falling down to 421, 421, 421. You can also plot the numbers with colors. You can make it even more tree-like. Isn't that wild? That they didn't tell it, we're going to make this look like a natural, actual tree. They just created an equation that did the same sort of processes that many trees actually do. This looks close to like a photo. I mean, obviously not quite on the bottom part, but that is very tree-esque. Now, a lot of great ways to visualize it. And one thing I wanted to note is I mentioned negative numbers can be worked in. Well, negative numbers have some different loops. And there's something I didn't mention in the episode, which was we can see the negative number loops as if we applied a similar but different process on the positive numbers. Well, when I take a negative number, if it's even, I cut it in half. As far as absolute value of the number, same thing that does as a positive. They both go halfway toward the number 1, or I'm halfway toward the number 0. And then, if we apply 3x plus 1, it's a little different. If I take a negative number and 3x it, same absolute value difference as 3xing a positive. But then plus 1 sends me further there, and plus 1 sends me closer to 0. So, like if I took 3, and I go 3x plus 1, I get to 10 because 3x is 9 plus 1. But if I do negative 3, I get to negative 8 because 3 is negative 9, and plus 1 sends me down 1 in absolute value of the negatives. So when I 3x plus 1 a negative, it's like I 3x minus 1 a positive. And in fact, it's an exact flip. If I said, what is the 3x minus 1 conjecture? Well, without having to look that one up, I already know that there are exactly 3 known loops. There's a loop that goes from 1 to 2, a loop that starts at 5, I think, as the smallest, and one that I think starts at 17. There are 3 known loops. And the reason I know that is because those are the known loops of negative numbers that follow the 3x plus 1 in a chain we know. And so we can sort of flip things sometimes. By looking at the negative numbers, we almost for free get the 3x minus 1 conjecture there too, which does have a few more loops. Interesting to note, if anyone likes the conjecture and thinks, oh, maybe there's something fundamental about the fact there's one loop. Well, 3x minus 1 could have a finite number of loops. That's more likely, maybe. That's what they're hoping to prove. But it has at least 3 loops. They don't all go into the same one. It's all pretty small low loops that they've found as far as the number sizes. Haven't found any loops that are like negative a billion yet. I mean, they would know if there was one at negative a billion. If they find one, it will be at like negative 1 quintillion. They've literally checked. I said 1 quintillion numbers they've checked for the positive cases. Not an exaggeration. More than 1 quintillion. That's a lot of zeros. But it takes more than checking to prove something. And that brings me to one other thing I wanted to note, which is every time I talk about this problem, somebody comments somewhere or says something somewhere about how they think they've solved it. This problem is so simple that not to solve, simple to describe, that it draws in people who have this idea that because the problem's simple, that maybe I can spend 3 hours and some creativity and crack that thing. And that's a cool idea. There's a lot of things in life you can do that with. There's so many open problems that 3 hours and some creativity could crack. But this question's been studied by so many great minds who the steps that I usually see in the proofs that people say they have used to prove this are so trivial that they're like condensed into the first few sentences of the proofs of other great mathematicians proving minor details about this in an attempt to get closer to the full proof. Now, some people are way too casual with how they say the word proof. Here, I tried to put out the names so we won't see the names. Here are a few Reddit posts, just because, everyone's subject to mockery, but tried to move out the name just to be a little nicer to whoever did this. I still think that whoever posted false proofs, even if I mock their overconfidence, they're cool, they're thinking about math. Good job, person. If any person I ever mocked the false proof of sees the video, I probably think you're cooler than the average person because you're trying on something or another. But these are people who we can learn a lesson or two from the cockiness of. When I looked on a certain subreddit that is dedicated for the main math subreddit moderators to send slightly crazier people to post, unfortunately got the name Number Theory. I wish Number Theory was dedicated to actual number theory and not dedicated to be the subreddit where you send slightly crazy posts. But whatever it's called, I got to admit, I find it kind of funny. Sometimes it's a sort of dark humor, laughing at somebody's overconfidence about they have proved something, but it's very interesting, and I find it a little funny as well. And I pulled up 3 examples of when you search Collatz there. Of course, many people say, I've proved this thing. In the last episode about Fermat's last theorem, I noted that I had read that some historians believe that Fermat's last theorem is the problem that over time has had the most amount of incorrect proofs submitted to institutions. And that as far as an officially submitted proof goes, the largest number of proofs have been submitted to that, because you don't need to keep submitting proofs for something that's already proven. Each one had to keep coming because all the previous ones were wrong. Now, this problem has been studied by such great mathematicians for so long that I'm sorry to the lovers of it, but it might not be one of the problems that takes just 3 hours in creativity. Like Fermat's last theorem, which had that trait historians think could be the most tried to falsely prove and submit it problem, would be nowadays at contest with this one. This one would be the other question that I've seen the most amount of false proofs of. It's a newer problem than Fermat's last theorem that was hundreds of years old. This one's maybe more like 80 or 90 years old, but it's catching up to Fermat's last theorem with how many false proofs get out there. Now, people, let's remember, if you make a really cool justification for something related to a problem, or a really cool instinct, or a set of things that you're not sure how to order them, or there's a few links missing, but you feel you got the point there, that's beautiful, but it's not a proof. So let's just use the word proof a little less and not need the word proof. Some people think like if I don't call it a proof, I didn't discover anything. No, you're rarely going to find something you call a proof. You're going to find a lot of cool facts along the way, though. Maybe a lot of new descriptions of things. Maybe tools that could add up to, I imagine, if the Collatz conjecture is ever solved, could be a similar length to Fermat's last theorem. You don't know for sure, but Fermat's last theorem took over 100 pages to solve. And that's one of the other simplest problems in math. And all the false proofs that thought they got that one in a page, and Fermat himself, who thought he had a really simple proof, unless he was trolling the world or something, probably were wrong and just thinking that steps added up to more than they do. Sometimes when you're putting together a proof, you get this step where you're like, whoa, I connected 2 things. And that feels so instinctively cool and right. There's something that's going toward that connection. And those are awesome. Write them down and share them with the world. But a proof is not one of those. A proof is many of those, and in between a lot of technicality. So when you write proofs, you gotta listen to criticism. That's part of why some of these posts get ironic, is that if somebody in the comments asks them, hey, here's something that doesn't quite make sense about your proof to me. Can you explain that part? How does that work? The people will get really offended and be like, man, you're trying to say my proof's wrong? It's like, okay, it's not on the other mathematicians to have to understand your proof. If you have the right proof, most of them will get it. When you're presenting it and more than half of them are finding something they don't get about it, then you need some tweaks till you get to the point where most of them get it. And here's just some funny examples. Let's see if anyone, this was posted on this number theory place. We'll maybe see their names. If we do, I'm not mocking these people and no need to look them up or whatever. It's a one-time example of people who tried to show the world that the reason I find it okay, even if it verges on mockery a little bit, is it's kind of problematic to tell the world you have a proof of something that you actually haven't checked with the mathematical community enough that it's not a proof. Sort of like if I said I had proved something and it turned out it wasn't a full proof of it, I would sort of be like, oh, this little stain on my record. So I would say that would make that moment very subject to mockery. I'm already subject to mockery. Trust me. We get plenty of mockery around here. It's good. It helps the soul. Now, this says, nice mockery. Don't be mean, people. I'm sort of joking. I'm just saying I feel a little bad even laughing at these comments, but if you don't laugh at anything, then you have a boring stream. But be nice to people. This person, though, said, let's see if anyone will take my proof of the Collatz conjecture seriously. Hi, everyone. Here's a brief proof of the Collatz conjecture. So, if somebody starts off this confident with a period right there, it's like, I really hope that you've either spent more than 10 years on this problem and or your proof is more than 50 pages and or you've had more than 10 other mathematicians check it and agree with it. Otherwise, let's just not say sentences like that, combo lords. This is a proof of something, period. It's okay to be unsure. It's okay to be like, this might be okay. They say if anyone can point out a mistake in the proof. This might be the one we did on the last stream, too. When I pulled up in a few, might be the same one that was just at the top of the thing when we noticed this last time. But I think this is an example of something really bad. It should, if anyone can point out a correct mistake in the proof. If there is one, it should take about 1 10-word sentence maximum to point it out. No. If you write a proof, or you're trying to demonstrate something to people, it is not on them to prove it all of a sudden. This is putting it on the viewer to prove it. It's like, what if I say, this candle isn't this penny, therefore the Collatz conjecture is true. If there's a fault in that, you have to tell me one sentence that's 10 words maximum to point it out. How are you going to do that? There's way too many flaws to try and make 10-word sentence. And so this is not what you should put in your proof. You should be very open to criticism. That's how you construct a good proof. Even Andrew Wiles on Fermat's last theorem, 30 years and a month or two ago, he presented it. Then they found that it wasn't quite perfect. And over the next year, they repolished it a bit. It was close enough that you can consider that first presentation as the math world knowing that, okay, this thing is basically solved. But they had to polish it up, and the final version was in 1995, not 1993. So, this is one we may have already seen, that a proof of the Collatz conjecture will not be this short. I'm sorry, folks. I know you love creativity and open problems, but you might need to find another open problem if you want to write a one-page proof and prove something. People have practically written all the possible sentences you could write on. Obviously not literally, but as an exaggeration, people have practically written all the ways you could combine mathematical sentences that add up to one page as a potential proof of the Collatz conjecture. So it's going to take more than a page. It's been tried. But if you want to say, here's one page that for some reason this looks to me like a proof of it, can somebody point out something's wrong? Is this a proof? Nothing wrong with that. You can ask if something you did is a proof. You can say, to me, this looks weirdly like a proof. But anybody who is going to solve this is going to know the problem well enough that they're going to know it would be such a shock to any real mathematician for it to be this short that you would have to preface any proof that was this short with like practically saying something about, despite it being ridiculously short, we have found this absurd loophole. Now, a lot of the loopholes people say either are using pretty simple things that are already known or define new terms and work in other terms that they're not using correctly. They're not using the term monoid correctly there. They're not using the word modular correctly there. So when you make up what words mean, you can prove anything. If candle equals the penny, well, candle's called A squared, this is called B squared, and C squared can't have the same exponent higher than 2. Therefore, I proved it. So you really got to be open to criticism. This person wasn't very much in the comments. Most of these people fight with the comments that try and do it. Here's another example. Looking for loops. If looping numbers exist. Now, this is less cocky in their overall presentation. But this is a funny example of they've made up a new term that's not well defined. So it's like me talking about candles. It's if looping numbers exist, the Cornelis conjecture is false. So it's like, okay, please very clearly explain what is a looping number if your proof hinges around, apparently if they're real, then the Cornelis conjecture is false. Well, they just like show some fractions that it's weird. You know, you can't even do the Cornelis chain to every fraction. They're working with some fractions and here they say, we have a 5-element loop here with looping fractions. They're not really applying this right, and they don't really formally explain looping numbers. It's like, where's the sentence that just says looping numbers are defined by... They're like talking about, well, try to find looping numbers the hard way. Bro, like, you have to actually define it. It can't just be a gut instinct of, I assume they mean a loop that does happen in the Cornelis conjecture when fractions are allowed. Something along those lines. Now, you got to define your terms if your new term is going to hinge on your proof. This person did put a good amount of thought into this, but please, dude, define your term. Now, this one's less cocky, but it sort of just leaves us in a corner. The fraction forms a 6-element loop. I guess based on their first statement, a loop means the Cornelis conjecture is false, if that's what they're saying. But they already said a loop all the way up here. So, if you're using completely different language than is normally used in the field of math, you have to define it at the beginning. You can't just say, well, I'm going to say 3 and this circle plus 1, and the circle is sort of this instinctual thing that means a type of number that falls into, you know, like a certain type of loop, and circles like that type of number. You need to like actually define your terms. One last one of these. Concise proof of the Cornelis conjecture. Below is a concise proof of the Cornelis conjecture. Okay. Now, I'm mostly just showing these because a lot of people, for some reason, whenever I mention this, comment about they think they've solved it. And nobody is doing that in this chat, to note. But in general, if you have a proof, you need every step to make sense to another person. Now, typically, the language you're going to use is going to be math. So you need every sentence to make sense to another mathematician. And if you're changing the language, you can change the language and define the terms. But some people have this idea that when they think they understand a proof, even if the whole world doesn't understand it, their gut instinct is stronger than the other people's criticism. And the gut instinct could be pointing towards something, but not pointing toward this is called a proof, because when you have the right proof, most people who are trained in the subject will read it and be able to understand it. That's like, what is a proof other than, like, we're humans. If I wrote absolute gibberish and I said this proves it on some quantifiable level that humans can't read, would we consider that a proof? A proof is something humans can understand, basically. And so, if other humans aren't understanding your proof, then it's time to say, should flock to some other open problems. This one's fun, simple. Feel free to work on it if you're not going to be overconfident with your answers, or if you're going to dedicate 10 years to it and maybe solve it. But there's so many open questions out there. There are open questions out there. that maybe you could put 3 hours and some creativity in one-page proof and solve. So I'll continue presenting new open questions to the world. There's been some recent ones, like the Ramsey numbers in an episode not long ago, and showing other open questions that, maybe people will have better luck at. Because this one, there are many quotes from mathematicians that say that they don't know if math is ready for this. And it's not that they first heard the problem and it was simple and the mathematician knew, oh, it's impossible. It's that they had tried so many things, all the things that are in a lot of people's proofs. They tried all of them and they didn't work. And they're like, well, we don't know how to prove this type of thing about infinity. And after a lot of work, when it's still unable to be proved, after the point, there's a 120 million yen prize on it. Let's see what that currently translates to in American dollars. I said between 8 and 900,000 because I wanted it to stay accurate for longer. And right now it is $835,854. You would get worth of yen if you solve the Collatz conjecture. And it's been open. A lot of people have tried it. And, if any of my fans want to dedicate 5 years to it or 10 years, then maybe you'll have a chance of cracking it. But I think a few of the people who are more I haven't spent that much time trying to crack this one on my own because I know I'm probably not going to dedicate years to it. And I know really good mathematicians have spent years and years and years trying a lot of the simple stuff. Of course, creativity can steer you in a different direction, but sometimes, even with creativity, to approach a problem that's already in a language and you have to use the language to answer the problem, sometimes the creativity has to be mixed with, a lot of stuff. Now, let's look at the opposite of that. By the opposite, I mean, we were looking at proofs that said they fully proved it and weren't actually doing anything new. What about a proof that didn't say it fully proved it, just said, hey, I made some cool work on this thing and was right? Well, that's the opposite end of the scale. What about in the episode when I said real quick, well, there has been some progress made on this from mathematicians over the years. Well, maybe mathematicians like a fellow named Terence Tao, who I've mentioned before. Terence Tao is arguably the greatest living mathematician. I don't think many people would say yet he is the greatest mathematician ever with all of the ones who have lived, but he's still going. He could be considered the greatest living by some people's subjective standards. And if I had to pick one, if I was on a game show and they said, what do you think was the most Steve Harvey goes, what was the most common answer that people said with that thing? I would guess that. Anyway, okay, getting confused. What I'm showing is I would guess that many people would have answered Terence Tao is getting to the point where it's pretty easy to consider him the greatest living mathematician because, you got to pick someone to give that subjective title to. And in other fields of math, some people might not say that, but we do a lot of number theory here. And this guy's done all sorts of cool stuff in number theory. He's one of the people who has pushed forward the twin prime conjecture closer to being solved. And now, as of about 2019, and latest edited in 2022, that's, here we can see, paper was submitted in September 2019 by Terence Tao, last revised in February 2022. He made a paper about how almost all orbits of the Collatz map attain almost bounded values. Now, let's see what it takes. Arguably the world's greatest mathematician, not to prove the Collatz conjecture. Oh no, he doesn't even know if this thing's solvable yet or not. To prove a sentence related to it that needs two almosts in it. These are technical almosts. Almost all and almost bounded will be defined in the paper. Almost all is already a defined term in this sense in number theory of what they mean by it. And it's just funny that compared to the cockiness of some people, I proved it. Great mathematicians sometimes put the word almost twice in their proof to make sure they're not overstating anything and not saying they proved anything they didn't. However, this is considered, with these almosts in there, they do have technical definitions, to be the biggest work that was proven on the Collatz conjecture in the last 10 years at least. This was in first 2019, edited 2022. This was a big fundamental push forward on that, hey, maybe we have more of a chance than we realize of solving this thing. Now, oh shoot, I didn't show the screen yet. Here. Almost all orbits of the Collatz map attain almost bounded values by Terence Tao. This is his long paper, one of his many great works that proved, it's not even like his biggest thing he's done. He just, spent, some many hours on this out of many things. This proves in many pages a sentence about the Collatz conjecture with two technically defined almosts in it. So that goes to show how even the better you get at math, the less you are like fiending for starting your paper with, I proved it. And the more you're okay with like understanding, if I even prove a step on this thing, but I make sure that it's fully clear and that I've actually proved that step, oh, it's an important enough problem. I know I'll go down in history. So that's a sign of a good math paper. Whatever you see in this paper are to contrast with those other proofs. Now, I love this dude. He has written such cool stuff. He had a blog for a while. I don't know if he still runs it, but sometime you guys should read some of his blog posts that are like a little casual, but kind of textbooky as well. And he'll just go into a random problem that he's interested in and like spend a month on that problem and like push it forward. And just like all the time. It's like, okay, I'm working on twin primes a year later. Okay, I've pushed forward some actual results about it. I'm going to work on the Collatz conjecture. What do you know? Biggest result of the last 5 or 10 years or more. And many other number theory results. Things about arithmetic progressions and all sorts of awesome stuff this guy has helped prove or proved himself. Very brilliant guy. And maybe someday we'll get him in the combo classroom. Someday we'll get some great mathematicians in the combo classroom and see how long they're willing to stay. We'll try not to accidentally Eric Andre show them too much. Like, I won't even mean to do it, but all the chairs slip in the mud. There's a lot of clocks ready to fall. So we're ready to have any great mathematicians who aren't scared of a falling clock. Now, those are a few Collatzian things. Let's see what we got next around here. Remember, the main, better done version of what I want to say about the Collatz conjecture, which is different than that, which is about it in binary, is linked in the description on the main combo class. Came out 2 days ago. Now, thank you for the other questions and thought or comments and such. Various cool ones going on here. And somebody says, except for the Unabomber. I think when I talked about the Unabomber, it might have been my biggest stream because I don't clickbait. I don't like to clickbait my streams, and I almost like undersell them at times because I almost have this thing in my head where I'm like, I'll have a title that sounds cool to make for a stream, but I'm like, what if I had a title similar to that for a main episode later that's a really cool project? And people think they've already seen everything I had to say because I titled some random stream that cool title. So I sometimes like undersell the streams to make sure that they almost seem a little different than the titles of my main projects or something. But because that one was like accurately titled like, oh, we're talking about a dead mathematician who just died, who killed a bunch of people, an evil mathematician by some standards, that one got a lot of views for a stream here because people, like that true crime stuff nowadays. There's stuff for us to dabble in there. Not that I have any interest in becoming a true crime YouTuber, but there's more dead mathematicians we can talk about, more murderers and stuff. Someday we'll definitely do the tale of like a Galois getting arrested for political reasons and then getting out, freed, and then or released, and then writing a letter that contained brilliant math theory that changed history on the week that he went out to have a duel and died in a literal duel. Like, actually got shot in a duel. Like, old-fashioned. Like, some people say, like, a math duel. Like, these people were doing, like, ooh, we're using the word math duel, meaning, like, ooh, some sort of game, some sort of challenge. Well, Galois got in a real duel. For the worse. Don't get in duels, folks, with a gun. He showed it. You know how I say, I eat the fruits, the weird peels and such you'll see in the next episode, so that you don't have to. So that you've seen one of us eat it, and you've seen a human do it. Now, you can do your own interesting things, and now you've seen this peel be eaten. No need to copy. Sometimes will even prove that certain things look dangerous or scary, and then you have seen that I looked scared in that time, and you would have looked scared in that time, and you can skip it. Similarly, the mathematician Galois can teach us, do not get in a duel. We only need one mathematician to try that for all of the rest of us to learn that it appears that there's a good chance you will die in the duel when you are very young. Galois was younger than I am. Called Galois theory, related to the insolvability of the quintic. Now, moving on from here, that's an example of a good proof. I don't know if all of you would understand it. I haven't fully read it, so I don't even know if I would fully understand it. I'll go through it later. But this is a pretty significant newer result that I didn't put in the episode. This is, part of the one sentence I said that real mathematicians have made significant progress over the years. I meant stuff like this. There are other similar things that prove traits about this function, but they're not as grandiose as some people think. Some people think like, well, there's kind of two questions. Do any numbers go into their own loop? And or do any numbers spiral toward infinity? So some people are like, hey, wait a minute. I think I've proved one of those. Maybe all the other mathematicians haven't gotten it for like that 100 years or so because they were trying to prove both of those. And they didn't just look at one of those. One, I can prove part of it. I can prove they don't go to infinity. Sorry, folks. The mathematicians have tried the separate halves. It's going to also take many, many pages and hours to prove either of those halves if you just do one of those halves. So, once again, this is not to discourage trying your own proofs. It's more so to note the bigger or the more popular of the open question that you jump onto to also try. It's good to try problems, but the more popular of the one you're trying, the less cocky you should be. The longer you should expect an accurate proof would be, because more things have been tried. And sometimes the simple ones trick people. If it's simple to describe, they think it might be simple to solve. Fermat maybe screwed the world when he left that margin note, implying that he had solved Fermat's last theorem in a really simple way. People for hundreds of years are like, it's got to be a simple way. Still, even there's still people to this day who are posting fake proofs online saying that I think I've figured out the proof Fermat had. I think that Andrew Wiles in the 1990s took 100 pages longer than he needed to. I think that 110 pages he did was totally unnecessary. I think I found the one Fermat had, and it's really short. Good luck, guys. Here's the thing. When you put out yourself to the world, you're subjecting yourself to some criticism. And it's not nice to criticize people for things that they are not, like, putting out to be like, hey, look at this. Like, don't criticize someone's looks unless they're, like, forcing you to talk about it or look at it. Because maybe they didn't want to put that to the world and they're just looking like that. But, for example, my channels are subject to criticism because I have decided I'm going to put this stuff on YouTube for the public to see. That makes it subject to criticism. And if you say you have proven something, you are holding yourself to the highest level of potential criticism. And people don't realize that. They're like, but I said I've proved it. We don't need to do the criticism. I said I've proved it. Other way around, bucko. If you think you've proved something, that means you're ready to go through the ringer of the highest level of criticism and make sure that it passes all of those, like 10 different mathematicians understanding it each and agreeing with it. So, for the last time, do try open questions. However, don't be cocky and maybe look up some other open ones that are more underrated than this one. Or invent your own. I don't work much on other people's open questions. From time to time in the past, I've fiddled around with twin primes in the way that other people who are more sensible fiddle around with collats, knowing there is the tiniest shred of a chance I will solve the twin prime conjecture, almost a non-existent chance, because I don't foresee dedicating multiple years to that single problem. If I did try and solve the twin prime conjecture, you guys would lose some years worth of an episode a week of other different topics. So if you're going to be like me or learn or think about a different topic every week, then maybe expect to prove smaller things. I don't expect to prove twin primes. Maybe I'll plant a seed for that. Maybe I'll prove something about primes that helps whoever proves twin primes. Maybe you'll plant a seed for the collats people. And my favorite can be my own questions. I love making up a question and seeing, all right, here's like a function. What happens if we have a random equation and we do this with fractions and some of them seem to do this? Do they all do that? Let's check it out. There's so many fun things I've invented that I've held off on putting in the episodes sometimes because I don't know what they build to. But we'll put more of those in bonus videos at times because I need to catch up the viewers on some of my own notes that I do in math that are the ones that sometimes I put on the back burner because I don't know if they're going to go to a bigger place for later or not, because they're like my own idea I was fiddling around with a concept about numbers I thought was cool. But sometimes it's fun to make up your own. So, for example, if I first heard about this collats thing, and I didn't know all this stuff, I might first think, oh boy, that's a simple sounding open question. Maybe I could crack this thing real quick. That thing sounds simple. Then I would hear, oh, hey, you know that thousands of false proofs have been submitted and, dozens of correct proofs making just minor steps toward the goal have been submitted and accepted that are just minor steps over the years, and that a countless amount of hours has been spent on this, both by amateurs and professionals. Then I'd be like, oh, okay, 3x plus 1 sounds kind of taken. Let's try 5x minus 3. I don't know. Maybe I'm different. Some people, the popular one sounds funner to prove. You're gonna get more fame if you prove 3x plus 1 than 5x minus 3. Which is probably more likely to prove fully things about smaller conjectures, including ones you make up. Because as Paul Erdős, who actually, has a funny transition, Terence Tao, as a kid, once met Paul Erdős because he was a child prodigy. He was really crazy good at math, even as a tiny kid. And he met with the old Paul Erdős to talk once and discuss math when he was pretty young. So there was just enough age to cross over. And let's pull up the classic photo of them as a transition, because now I want to say the Erdős quote. Maybe this is part of why Terence Tao decided to dedicate a while to this problem, because, this was somebody he must have looked up to. One of my favorite mathematicians, Erdős. And there's a tiny Terence Tao studying with him. Now, Erdős said, he's gone now, but, or we'll just say dead, so, it's, to be extra clear, he's not missing or anything. But Erdős said about the Collatz conjecture, let's get his quote up here. He thought that he offered $500 for its solution. Now there's that 120 million yen prize. But Erdős loved making prizes. He was like, all my extra cash is going toward trying to get people to solve this random problem. I'll give you $20 if you solve that thing I'm curious about. I'll give you $50 if you solve that one I'm even more curious about. So this one he offered $500 for. That's, I think, one of his bigger prizes. He wasn't a rich guy or anything. And you know what he said about this? Mathematics is not ready for such problems. What he means by that is that this represents a category of proof about infinity that wasn't provable within the techniques and frameworks that we had for other proofs that were successful that exist in math. And that after so many hours of trying, and this seeming like it does not interlock with those and would need something else, and it seeming hard to know, what is that something else that could prove this type of thing about an infinite set of natural numbers that wasn't provable by whatever proved Fermat's last theorem and all of infinitude of primes and all that? Well, maybe it's going to take a long time. Maybe mathematics needs some weird breakthrough in a different field to be like, whoa, we proved this other thing about the number 71. And it turns out the number 71 has these crazy traits about all the natural numbers. And then they're like, wait a minute. That technique sounds like something we could try on the Collatz conjecture. And if you see my episode about Fermat's last theorem, that's what happened on Fermat's last theorem. It was about 300 years old or so. And Andrew Wiles cracked it because not too long before that, this other conjecture, now known as the modularity theorem, then known as something like the Tanimaya-Shimura conjecture or something, now often called the modularity theorem, was proven as a separate thing in math. Totally different. Modular forms and elliptic curves. But then they proved a link. And they proved that, hey, if we prove this thing, we get that thing, and sort of like knocking over a bunch of dominoes. If we can knock over that domino's going to tip. So Andrew Wiles managed to knock over the first domino once they had known that if this domino's knocked, Fermat's last theorem is going to. In fact, when he presented the proof, it was more so a proof of the modularity theorem. And at the end, he was like, and I don't know how he phrased this. I need to look up the details if you want an exact quote. But it was something along the lines of, at the end of his presentation about the modularity theorem, he reminded, any mathematicians who happened to remember, and most of the crowd who might not have remembered or known this, that You guys know that because I've now proven this, and this other link that was proven not long ago, that this proves Fermat's last theorem too. So it's not like he was proving Fermat's last theorem by saying, okay, how do I go about the A's versus the B's versus the C's in this equation? It's like that equation got very distanced from the proof techniques. So don't be surprised if the proof of the Collatz conjecture is like stuck behind a brick wall of some proof technique that some other field of math will have some breakthrough someday. And maybe 80-year-old Terence Tao in like 40 years or 30 years will solve some other random thing. And then they're going to realize, oh, whoa, we knocked over some dominoes. That proof technique can do that too. This thing is linked to that. So, I'd say that, Erdős was right about a lot of stuff, so I don't know the state of how solvable the Collatz conjecture could be. I gave all of my hypotheses and thoughts in the episode I made recently and in this stream. But I'm prone to trust Erdős. This guy knows what he's talking about, usually. And he did seem to think, out of all the open questions he loved, oh God, I'm upside down. What have I done? Oh man, what have I done? No. Oh, come on. Someone needs to join my team and be my tech person. Okay. Now, Erdős was really into open problems. If you read this quote when you hear someone say mathematics isn't ready for such problems, you might think that's like a closed-minded person, if that was the only quote you knew from them. Not at all. He gave away all his money on prizes on stuff like this. The fact that this one was 500, I wouldn't be surprised if that would have almost bankrupted him, but he was pretty sure nobody would solve it in his lifetime. Because a lot of the other problems he thought were more solvable and had smaller prizes he could afford. And also this was back in the day, so that's worth more. With inflation, it's going to be anywhere from 2 times to 10 times as much nowadays. I would have to look up what year this was. But, he's the type of guy who really liked open problems, who studied many of them, believed many of them could be solvable, and pushed forward much work on them on his own. He solved many things too. But thought that maybe mathematics is not ready for such problems. There's one other quote I had written down somewhere that... What's another of the common quotes that's along those lines? One moment. Here's another one that is another mathematician, Geoffrey Ligarius, said a similar thing, though that I also copied down with the Erdős one there because they were together, which was, it's an extraordinarily difficult problem, completely out of the reach of present-day mathematics. Neither of those people are saying it's unsolvable. That doesn't mean, like, it could be solved tomorrow. What it means is that you're going to need some crazy combination of all sorts of stuff from mathematical history that for some reason we haven't combined yet, mixed with something new maybe. But with your new thing, you got to define it very carefully. You can't just be saying whatever that one guy was saying about, like, oh, you got any loopers? Oh, yeah, if you got any loopers, then you proved it. So we're looking for the loopers. You got to define the terms. So many mathematicians believe Collatz conjecture could easily be, we don't even know if it's solvable. It could even be proven that it's unprovable in certain ways, that certain aspects of it cannot be decidable or other mathematical traits like that. But we don't know that either. So it could be proven that we're not going to be able to know everything about it. Could be proven one of the 3 main possible results, ascend toward infinity and or other loops versus all go down to 1, 2, 4. And I would say that if I had to guess, I think there's a way a human or an alien could solve this someday. But I wouldn't be shocked if it's more than 100 years from now. And I would be shocked if the proof is less than 10 pages. So, and another bad sign with a lot of the proofs, you'll note, a lot of these really short proofs aren't even using the space that efficiently. Like Terence Taub's proof here, he assumes that people know a lot of things about math. He doesn't take half of his first page saying, so there's this cool thing called the Collatz conjecture. The way it works is we could cut a number in half if it's even. Do you guys realize this means that powers of 2 are already solved? So yeah, we got that powers of 2 follow into it. Just got to make sure you get that. Like Terence Taub assumes his audience is way above that, knows a lot of that stuff already. And so they jump right into it, you know. A lot of the other paper or proofs, it's a bad sign of a proof if they're saying things that you expect that anybody who would be reading this paper would probably know. You don't need to take time in your proof to say, the commutative law is the one that states this, and we're using that. You can just say, based on the commutative property, and assume a mathematician should know that. With the Collatz conjecture, there's certain things that, if you're a mathematician who studies this, you assume anyone who's going to analyze your paper is going to understand certain things pretty quick. That if you're just like, it should take you only a sentence to say the part that every power of 2 automatically will spiral down to 1. Maybe 0 sentences. Might not even be in here. Might just be assumed. So, whereas other people take a paragraph. Like that's like my first main result. So, remember, if you write a proof, it's nice to fill it out and make it really clear for everybody. If it's a proof of a general thing, maybe add more of that. But a proof of the Collatz conjecture, if it starts out with describing elementary arithmetic and how it works, it's like, ooh, that's a bad sign. You're not using your 2 pages well. You know, Andrew Wiles had to be pretty dense to even fit Fermat's last theorem in 100 pages. One of the big tasks of mathematics for the future is going to be to condense the longest proof ever. There's literally one that you can say is the longest proof ever. Normally, you'd be like, I don't know about it, maybe in another country or another time. No. If you accept something as a formal proof, as one thing with certain standards, you could define there is one longest proof ever. It's more than 10,000 pages. It's the the classification of finite simple groups. So let me pull that up. Classification of finite simple groups. This is something that mathematicians would love to be as short as possible. It describes all of the families that are called simple groups in group theory, which we'll go into someday, and proves that these can be the only finite simple groups, and these are what they are. Well, mathematicians would love for that as, you know, simple sounding. You know, obviously we haven't defined all the terms, but it sounds kind of simple. Okay, it's a thing called group theory. There's types of things in it called groups. Some of them are called simple. Some of them are infinite versus finite. Well, this paper is saying we know all of the finite simple ones, and here's the proof that these are the only ones there can be, and these are what they do. Well, once again, sounds kind of simple on the surface to a degree, but as you go in, you're like, okay, this proof not only was 10,000 pages, that they have barely been able to condense because they're having trouble cutting it any shorter without losing any of the accuracy. Like, if you imagine your paper, you don't write your proof like it's filling out words to get your word limit for high school. Imagine it as condensed as possible, because eventually we'll want it as that. We want the proof as short and sweet as possible. Well, as short and sweet as they were able to get this was 10,000 pages. Many, many authors over many years, compiled by a few people, and although it is accepted in the mathematical community that it's almost definitely true, I mean, it's accepted as true. It's just good to, say almost sometimes, like Terence Tao. But it's, we're pretty sure mathematically that this is fully safe and sound and just needs to be shortened. But not many mathematicians have read this whole thing. I mean, and by read, I mean, let's assume if you start reading it and you don't understand it, you're not going to read 10,000 pages. So unless you're like trying to prove a point to someone, we're not counting someone who's like, I want to be able to tell my bar friends that I read 10,000 pages of a proof. No, people who actually read it and paid attention and stuff to all of it and understood it. There's got to be less than 1,000 people on Earth. So maybe someday, if I'm old and I would say retired, but I'm not going to retire. I'm always going to make these videos, and write books and stuff. If I am old and half retired or whatever, maybe someday I'll go on the quest to try and read this paper. I don't know if I will ever get to the point of being like one of the couple hundred people on Earth who have probably actually read every word in this and understand it. Took so many people to put it together and connect each other's bits. So, what are the groups? Where is the list of finite simple groups? I forget all their names. There's the monster group, of course, I remember. That's a classic. But here we got... these don't really make sense if you don't know any of this. And even to me, who I know a little bit of group theory, some of these I don't know what they are. So each of these is its own story. I only know about some of these. Now, monster group, that one's pretty popular and cool because wowie zowie does that one have the biggest number in this column. We're going to look at group theory someday because it is a pretty beautiful underlying structure of certain tables that can be said to describe symmetries of objects. Also, some of them turn into the modular arithmetic tables we've made. Other of them can describe ways of rotating shapes. Others can describe... It describes so many things about reality. But they're these tables almost that the group is actually almost just a table of interactions in a way. But these tables sometimes are so fundamental that there's like... The one we're going to really go deep on. To start, I mean, the easiest one for you folks to understand from where we're at is when I did modular arithmetic about three-even numbers, well, a little chart about adding three-evens, and another little chart about multiplying three-evens. What else do those maybe apply to? Like when I replaced pre-three-even Throd with congruent to 2 mod 3, that described a different thing in a way, but was pretty similar. What if I could find groups that are like, okay, this describes the way that the number I hops around things. It also describes traits about the number 4. It also describes things about this square. Well, yep, that's a group that describes all of those things and more. Different than the three-even one. That's a more four-even one, which we don't need to have a word for because it's called doubly even. But yeah, group theory is a whole nother story. That's not going to be this grade. Group theory will probably be a grade or two out. But it will come. Now, let's see. Oh, someone's birthday. Happy birthday there. And we are going to wrap up our stream pretty soon. I do love all of you who have joined me for a random bonus late night one, or anyone who has join this in the future to watch our fun future. As people know, they always go up right away in SD, and I can't speed it up. It takes YouTube a little while to put the chat up and the HD up. So if anyone like refreshes it and they're like, what? I was in the chat. Where'd it go? It comes back after a few hours. YouTube takes a little while. But they are always available to watch. So if anyone misses any of the streams, you can just be like, all right, when I'm bored later, go to that live tab on the Domotro channel. And when I'm extra ready to learn, I'll go to that videos tab on the combo class channel. Now, another thing I almost talked about that we're going to save for another stream soon is I have still been doing weird math with these magic cards. I know it sounds silly and like I'm not interested in anything like buying any of them, certainly. But I have all the old ones I used to have when I used to play this game. And I have gone down a rabbit hole of a singular challenge that is essentially the challenge that I don't know if anyone else has fully researched. That I'll describe it more in its own stream in a day or two. But I've made a very mathematical, like, it can be rigorously demonstrated, if you have achieved the thing or not. And it's something that it takes proofs to prove you're at a certain level. I had to do a proof of sorts to prove that I had created a 20 card version of this challenge I'll show. And now we're going for more cards in the challenge. In short, it relates to a deck that always wins, which is always wins on the first turn, which we do have to define certain principles about, the opponent not having any magical tricks up their sleeve and things like we can't do it with 60 card decks if we restrict to up to 4 of a card like the game typically allows. But what's the most amount of cards that it is possible for? Now there's more restrictions and more twists. It's going to eventually probably have to be a whole combo class episode because I've gone through many twists on this road. But I've gotten to the point where I've developed a deck of cards of them that may be bigger than one anyone ever has planned any research around. I don't know if anyone studied this mathematically. People think about, I've seen surface level topics of this, but they've never gone to the actual level that I'm doing this particular question, which is very calculated and calibrated. I've designed a 20 card deck that under my standards always wins under the first turn. I think I've gotten a 21 card deck, and I'm playing around with the cards because I think I can get a little higher. So it's a strange challenge, but that's a weird little game theory thing we'll do next time. We also are going to need to see what the squirrels have been up to. They hid some pine cones somewhere weird. They're hiding pine cones in the classroom. So instead of describing that, I'll just do another stream in a day or two out in the classroom, and I'll show you. The squirrels are hiding these pine cones now. So, as usual, fun wildlife out there. Stay tuned for, apart from other bonus streams and such. Oh, cat came in at some point. Want to go out, Sage? Sage? You came in the window? Hey, Sage. Alright, yeah, he wanted to go out. So, stay tuned for, apart from cool live streams and stuff that will continue coming, and some shorts and such that will be coming, for the snack break that's about the edible peel conspiracy. Should be out sometime this weekend, maybe Friday, more likely the weekend. And that's a really fun one. Even though it's less mathematical, it is important. And I hope anyone who's joined me today or in the future has a marvelous day or night wherever you're at. I am going to wrap up this stream now, but next time we'll be back in the combo classroom, and I do have a lot more fun stuff to share. So make sure you've checked out all the cool links and stuff. Make sure you know about our Discord and Patreon and blah, blah, blah. I love you all so much, and I will catch you later.